In this video, I'd like to prove two of the properties of logarithms, namely the exponent property and the product property. And they state that, well, the exponent property states that the log base b of x to the y is equal to y times the log base b of x. So we'll call that property 1. That's the first property that I'll prove. And the second one is the product property, property 2, which says that the log base b of x times y equals the log base b of x plus the log base b of y. Okay, so we'll start with this first property, the exponent property. And let's just make this statement. So let y equal the log base b of x. If y is equal to the log base b of x, this implies that b to the y is equal to x. So let's take this equation, b to the y equals to x, and let's raise both sides of this equation to the wth power. So raise both sides to the power of w. This side to w and this side to w. So then, this leaves us with b to the y times w equals x to the w. Now take the log base b of both sides. So take the log base b of b to the y w. This equals log base b of x to the w. And here we have composed inverse functions, which means we get back our input. In other words, log base b of b to the yw is just yw. So yw is equal to the log base b of x to the w. And now if we go all the way back to the beginning here, y is equal to the log base b of x. Well, here's y, so y is the log base b of x. So I have the log base b of x times w equals the log base b of x to the w. And since multiplication is commutative, I can just switch the order of these two. So I can just say that w times the log base b of x equals the log base b of x to the w. And that completes the proof for the exponent property. Now let's look at the product property. So for the product property, we have to have two different logarithms. So let y equal the log base b of x and w equal the log base b of, let's say, u. Okay, so let's look at the exponential form of these two logarithms. This one says, so say then, b to the y is equal to x, and b to the w is equal to u. Okay. So this implies, so b to the y times b to the w is equal to x times u. But b to the y times b to the w, that's b to the y plus w. This equals x times u. And now, take the log base b of both sides. So the log base b of b to the y plus w equals log base b of x times u. Now again, here I've composed inverse functions and I get back my input, which is exactly y plus w. So log base b of b to the y plus w is just y plus w. Y plus w is equal to the log base b of x times u. But remember what y and w are. Y is a log base b of x, and w is a log base b of u. So substitute back in, and you have the log base b of x plus the log base b of u equals the log base b of x times u.